Welcome back, Stella. So today we're going to do what is that exercise? We're going to do this first one, exercise 4A sub 1 and B sub 1 and sub 2 for question A sub 1. You understand? So we are to solve exercise 4A sub 1. We are to solve on R. I told you when we are solving on R, it simply means we are finding the general solution. I first want to mention something about general solutions. Look at something here. What do you notice about this? Y equals to x plus 2k pi and y equals to minus x plus 2k pi. This, in some textbooks, the whole of this thing can still be written as this. There is 2k pi here, there is 2k pi here. It can still be written as y equals to 2k pi plus or minus x, because what, there is plus x here and there is minus x here. So don't be don't be confused if you see in some textbooks that the general solution to this, the general solution to don't be confused when you see in some textbook that the general solution to of course is 2k pi plus or minus x. It comes from here. There is 2k pi here, there is 2k pi here. So these two can be combined in such a way that we have plus or minus here. Is that okay? When you break down this, you either have this or this. Is that okay? But for this one, there is no possibility of breaking, so you have to use these other ones. Is that okay? So when you are using the general solution, of course, you can also state it like this. Is that okay? Why I'm precising your k belongs to what? The set of integers. So don't forget that. So don't be confused when you see this in some textbooks. This, if you want to convert it into degrees, this 2 times pi is 360 degrees. So it will still be equals to 360 degrees k plus or minus what? X. You guys are always fond of putting n here, so it depends on you. So don't be confused when you see that in some exercises. Is that okay? Very good. Okay. So we're going to do the next exercise. Where is it? We're going to do this exercise 4a sub 1, 2 cos square x minus cos x equals to 0. Okay. Exercise 4. Exercise 4. A sub 1, 2 cos square x minus cos x equals to 0. Our aim is to solve it on what? On R. That's the question that was asked to us. So we have to find what? The general solution. Is that okay? Okay. Here, how am I going to solve it? This is very simple. I'll factorize cos x here. So this will give me cos x into 2 cos x minus 1 equals to 0. So I'll simplify this. This implies the system. This implies either cos x is equals to 0 or 2 cos x minus 1 is equals to 0. This implies cos x is equals to 0, or what, or cos x is equals to a half. Is that okay? So I told you in mathematics, O means union, so you have to find the solutions of this and you will do the union with the solutions of this. Is that okay? Since when we are dealing with general solutions, the union will be just putting them in the same set with precising the value of k. So let's proceed. So we have to solve either cos x equals to 0 or this. So let's start by solving cos x being equals to 0. Okay, let's start by this. Okay, we are finding the general solution because we are solving on R. We have cos x being equals to 0. This implies cos x will be equals to what? Cos inverse of 0. Is that okay? What is the cos inverse of 0? The cos inverse of 0 is, when you look at the trigonometric function, what angle gives, if you can use your calculator, what angle gives, the cos of what angle gives 0? It is the cos of what angle gives 0? The cos of pi on 2. Yes, it is the cos of pi on 2 that gives 0. Since cos inverse of 0 equals to pi on 2, it implies cos x must be equals to what? Cos of pi on 2. Is that okay? Perfect. Now, we simply need to apply our general solution of cos. So this implies, or it's imply what? X will be equals to 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 pi on 2 plus 2k pi, or x will be equals to what? Minus pi on 2 plus 2k pi. Is that okay? With k belonging to z. If let's also try to give the general solution in this form. Wait, let me show something in this form. Let's give it in this form. Let's try to give it. Where are we? We are here. Now you see that there is 2k pi, 2k pi. This angle is there is this angle and there is minus here. So you can also say that the x, you can also simply say that x is equals to what? 2k pi plus or minus what? So this x is equals to 2k pi plus or minus what? This pi on 2. Pi on 2. So that's the general, that's the thing. So so this implies the general solution S1 for this will be what? Any number of this form, pi on 2 plus 2k pi, or this, that is pi on 2 plus 2k pi plus 2k pi, comma, minus pi on 2 plus 2k pi, with k belonging to the set of integers. Here, k belonging to z. So you can either give the general solution for this first one as this or this. Is that okay? So feel free. So this is the first general solution. Let me write it well. This is the first general solution, because we have to solve this or this. So we have to find the general solution of this union, the general solution of this. Is that okay? Now we have solving for cos. for cos x being equals to a half. Is that okay? Solving cos x. Okay. Cos x being equals to a half implies cos x will be equals to cos of cos inverse of a half. Is that okay? I hope you understand why I'm writing it, because the cos of cos inverse of something is that thing. Okay, now the cos inverse of a half, the cos of what angle gives a half is 60 degrees, that is pi on 3. Since you can have it with your calculator, since cos inverse of a half is equals to 60 degrees, which is equals to pi on 3, it implies cos x will be equals to cos. So I replace this cos inverse of a half by pi on 3. Cos of pi on 3. Is that okay? Perfect. That's perfect. So this implies this implies this implies or it's implied by this already in the general solution form of cos x. So I will have x being equals to pi on 3 plus 2k pi, or x being equals to minus pi on 3 plus 2k pi. Is that okay? Plus 2k pi, where k belongs to a set of integers. Or you can still give the general solution in which form? Our x will be equals to what? You write here 2k pi plus or minus what the angle does here, plus or minus pi on 3. General solution with k belonging to what? Z. Is that okay? You see that is the same thing. You have your 2k pi and you have what? Pi on 3, yes, plus minus pi on 3. You have it. Is that okay? Now, so this implies in this second case the general solution S2 will be equals to what? Any number of the form pi on 3 plus 2k pi minus pi on 3 plus 2k pi, where k belongs to z. You get what I'm saying? Or for example here, you can decide to give instead this one. You can decide instead of giving this, you give S1. The general solution is what? 2k pi plus or minus pi on 2. That's the general solution, where k belongs to z. Is that okay? Here also you can decide, or you can say using this one, you use instead this one, S2 equals to what? 2k pi plus or minus pi on 3, where k belongs to z. Is that okay? Now you have to find the general solutions, because the solution to this equals to 0 was either this is equals to 0 or this equals to 0. You get what I'm saying? Either this equals to 0 or this equals to a half. So this all means union. So I solve this and I do the union with the solution of this. Is that okay? So this implies, so therefore the general solution on R S will be equals to what? S1 union S2. Is that okay? So this implies S will be equals to what? I'll first take this one. We have pi on 2 plus 2k pi and minus pi on 2 plus 2k pi. We have pi on 2 plus 2k pi, and we have minus pi on 2 plus 2k pi, comma, the next will be pi on 3, these other ones, plus 2k pi, and minus pi on 3 plus 2k pi, with k belonging to the set of integers. That's the general solution to that system. Or you can decide to write the general solutions using instead these other notations. You get what I'm saying? So this S1 will be 2k pi plus or minus pi on 2, 2k pi plus or minus pi on 2, comma, and this other one, 2k pi plus or minus pi on 3. Is that okay? 2k pi plus or minus pi on 3. Is that okay? Very good. So that's how you go about doing things. Okay, that was the first part. The next part, let me see. Okay, the next part, where is it in? Question. Okay. Okay, the next part, deduce the B sub 1. They say deduce the solutions of the above equation on the interval minus pi pi. So they want you to find the solutions of this on the interval minus pi pi, and on the sub 2 you are going to find it on the interval 0 180 degrees, that is 0 pi. You understand? Okay, that's B sub 1, the B sub 1. Okay, let's proceed to that. So on the so this was question A sub 1. Okay, let's deducing. Okay, the sub 1, B sub 1, deducing solutions of A sub 1 on minus pi pi. Okay, we have to deduce what? We have to deduce the solutions on this interval. We have already the general solution. This was the general solution. These were the general solutions. Is that okay? These were the general, yeah. These were the general solutions. These are the general solutions. So we have to take each of these ones and put it on this interval to find the corresponding value of k. Okay. Recall that the general solution. Recall that the general solution to solution to A sub 1 was S being equals to, we have pi on 2 plus 2k pi, comma, minus pi on 2 plus 2k pi, pi on 3 plus 2k pi, minus pi on 3 plus 2k pi, where k belongs to z. Okay, so we have to take one by one, we have to take this as we usually do. We take this, we find the values of k that will satisfy it on this. We take this, fine, take this, fine, take this, fine, and we give the 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 final result. Okay, for x being equals to pi on 2 plus 2k pi is for this first one. Recall that x belongs to what? Minus pi according to the exercise. That is, x is strictly greater than minus pi but less than or equals to pi. This is our x, so this implies pi on 2 plus 2k pi must be strictly greater than minus pi but less than or equals to pi. So we divide all through by pi. So this we are going to have a half plus 2k greater than strictly greater than minus 1 but less than or equals to 1. Very good. So this implies we have to subtract a half from each part because we have a half here. So I will have minus 1 minus a half, strictly less than 2k less than or equals to a half minus a half. Is that okay? So this will give, so this times this, I'm going to have minus 3 on 2, and here I have 2k less than or equals to a half. I'll then multiply all through by no, I'll divide all through by 2. Yes, for me to have k here. So this implies I'll have k greater than minus 3 on 4 less than or equals to 1 on 4. So we have already the interval of our k here. When we draw it with, let me first convert that into points. Let me first convert that into points. 3 divided by 4, 3 divided by 4, 3 divided by 4. This is minus 0.75. K less than or equals to, this is 0.25. Let me check it. 1 divided by 4. Yes, 0.25. Now we see that in this first case, our k will have 0.75 minus, this is close, no, this is open. The circle here must be an open circle. Open. This is 0.25. This is close. Now, if this is minus 0.75, it means that there is a 0 here. There is a 0 here. And after here is minus 1. So these are the numbers that are concerning us here. These are the numbers that are the integers that concern us here. The only integer that's present here is what? K equals to 0. Is k is 0. So k must be equals to what? 0. Very good. When k equals to 0, what do we have? When k is equals to 0, this is where we are supposed to substitute it. When k is equals to 0, x equals to pi on 2 plus 2k, 2 into 0 pi. We're substituting here. So this will give, it implies x will be equals to pi on 2. So on the first for the first one, we know that the solution must be equals to what? Pi on 2. Is that okay? Perfect. Let's now go for this other one. we have for x b equals to minus pi on 2 plus 2k pi. Okay, let's do this. Recall that x belongs to what? Minus pi pi. Is that okay? That is, x must be strictly greater than minus pi but less than or equals to pi. Okay, I'll take this x and substitute it here. So this implies our minus pi on 2 plus 2k pi strictly greater than minus pi but less than or equals to pi. Is that okay? Okay, I divide all through by pi because their pi is common. So this implies I will have minus 1 less than minus a half plus 2k less than or equals to 1. Now I need to remove this a half minus a half here. So I'll add a half to each part of this inequality. So this implies I'll have minus 1 plus a half less than I'll have minus a half plus 2k plus a half less than or equals to 1 plus a half. So this implies I'm going to have what? This a half and this will go. This will leave 2k strictly greater than, this will give minus a half less than or equals to 3 on 2. Is that okay? Perfect. So this implies our k will divide all through by 2. So k will be strictly greater than minus 1 on 4 but less than or equals to 3 on 4. Perfect. So this will give k strictly greater than minus 0.25 but less than or equals to 0.75. Yes, that's it. So if I represent it on a number line, so this is minus 0.25 and here 0.75. So this is where our integers must lie. This is minus 0.25. So here naturally I will have what? 0. You understand? Because after this I'll have minus 1. So the only solution in this case for k is, so this implies our k must be equals to what? 0. When k equals to 0, what is x? Let's substitute it here, inside here. So we are going to have minus pi on 2 plus 2 plus 2 into 0 times pi. We are substituting things inside here. So this implies our x will be equal to what? Minus pi on 2. So this implies the second solution is what? Minus pi on 2. Okay. Ok, on va faire maintenant la même chose pour ceci. We're going to take this now and do the same thing. So I will have this is pi on 3 plus 2k pi. Pi on 3 plus 2k pi. For x equals to no, for x equals to pi on 3 plus 2k pi, for x equals to pi on 3 plus 2k pi. For now, recall that x belongs to minus pi pi. That is, x is strictly greater than minus pi but less than or equals to pi. We take this and substitute it here. So it implies we're going to have pi on 3 plus 2k pi strictly greater than minus pi but less than or equals to pi. Now, if we say this is an opening, c'est opening, inequality opening. Il faut attention. Inequality is open here. It's open, not close. Yes. Okay. Now this implies I'll divide all through by pi, so I'll have here 1 on 3 plus 2k strictly greater than minus 1 less than 1. From there I'll subtract 1/3 from both sides. This will give me subtract, I'll have here minus, I'll have 2k strictly greater than minus I'll have minus 1 minus 1 here. So I'll have minus 4 on 3 less than or equals to 1/3 2 on 3. Perfect. So this implies k will be strictly greater than minus 4 on the 3. Minus 4 on 3. No, minus 4 on 6 less than or equals to 2 on the 2 on the 2 on the 2 on the 6. Yes, 2 on 6. So it implies we'll have here 4 divided by 6. 4 divided by 6. I'll have 0.67 minus 0.67 k less than or equals to 2 divided by 6. 2 divided by 6. 2 divided by 6 we have 0.33. 0.33. So this implies from here we deduce that the only integer between this and this, when we draw the number line, will simply be equals to 0. Yes, that will be the only integer. Let me see. Yes, when we draw, if this is minus 0.67 and this is 0.33, the only integer between is 0. So this implies when k equals to 0, 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 what do we have? Our x will be equals to what? This was our x up here. This is our x. Pi on 3 plus 2k pi. Our x will be equals to pi on 3 plus 2 into 0 times pi. So this implies x will be equals to pi on 3. Perfect. Okay, now for the last one, for x equals to minus pi on 3 plus 2k pi. Okay, recall that x belongs to minus pi pi. This implies minus pi on 3 plus 2k pi will be strictly greater than minus pi but less than or equals to pi. We divide all through by pi. We have, this implies we're going to have minus 1 on 3 minus 1 on 3. We're going to have minus 1 on 3 plus 2k strictly less greater than minus 1 but less than or equals to 1. Okay, perfect. This implies we're going to add plus we're going to add 1/3 to each part, so this will give a half. Minus 1 plus 1/3 will give me minus 2 on 3. Yes, so I'm going to have minus 2 on 3, and here I'll have, if I add 1/3 here, I have 2k less than or equals to 1 plus 1/3 with 1 plus 1/3 will give me 4 on 3. Perfect. So this implies I'm going to have k strictly greater than what? Minus 1 on 3. Yes, the less than or equals to what? We divide all through by 2. This we're going to have 2 on 3. Perfect. So this implies our k is strictly greater than minus 1. Okay, 1 divided by 3 is 1 divided by 3 is 0.33. So I will have minus 0.23 here, less than or equals to 2 divided by 3. 2 divided by 3 is 0.66. So this is 0.67. Yes. So we clearly see that if I'm to draw it on a number line, this is minus 0.33. This is 0.67. It is open here and close here. So these are the integers that are supposed to satisfy here. The only integer that's present here is what? 0. So it implies our k must be equals to 0. So this implies when k, which I did not conclude it here. Here I was supposed to conclude that S3, the general solution, will be pi on 3. Is that okay? Here, when k equals to 0, we go and substitute it here. When k equals to 0, the answer is x is minus pi on 3. When k equals to 0, x will be equals to minus pi on 3 plus 2 into 0k pi. So this implies our x will be equals to minus pi on 2. So this implies s will be equals to, this implies our s will be equals to this implies our s will be equals to yes, our s4 will be equals to minus pi on 3. Now, we have already found for every general solution. Now, we can then conclusion that the general solution, the set of values of x that satisfy find on this interval, find on the interval minus pi pi, that satisfy this equation, which satisfy, where is our equation, which satisfy this equation, are given by, yes, the set of values of x which satisfy this equation are given by, are simply given by s will be equals to s1 union, because remember that the general solutions are unions, because they are all at the level of answers. So s1 s will be equals to s1 union s2 union s3 union s4. So this will be equals to, we have pi on 2 union minus pi on 2 union pi on 3 union minus pi on 3. So this implies our s will be equals to the smallest. To know which is the smallest, you just convert. If you take pi on 3, you just convert this pi into 180 degrees. 180 degrees divided by 3, that's 60. So this minus 60 degrees and this minus 90. So we have we're going to have minus pi on 2 minus pi on 3. After that, we have pi on 3 and pi on 2. So that's the solution on the interval minus pi pi. That's the solution. So so that's the general that's the solution for that equation on the interval minus pi pi. You are going to do let me see, you are going to do the b sub 2 of this one. You're going to deduce the solution on the 0 180 degrees. You understand? So you are going to deduce the solution. Me, I can already deduce it without even doing the calculation, because this interval gives already, if you notice something, this interval 0 180 degrees is found in this interval, because the interval minus pi pi is the same as minus pi 0 union what 0 pi. It means that if you have already find solutions on this, you just choose between those solutions you are find, the solutions which are inside here. I don't know if you are trying to get what I'm saying. This interval is equals to what? Minus pi 0 union 0 pi. It means that if I have already find the solutions on this, it means that the solutions is, since this interval is equals to this interval union this interval, and this interval is this, it means that since I've already find the solutions on this, I'll just find between those solutions which are the values that are found on this interval. From there, I'll deduce instead of wasting time again. So this is what I'm saying. We have to do the b sub 2 for a sub 1, for question a sub 1. Deducing, we have to deduce solutions on what 0, 180 degrees. Very good. We know that from B sub 1 we had from B sub 1 we had S being equals to minus pi on 2 minus pi on 3 pi on 3 pi on 2 with what? With x which was belonging to what? Minus pi. Is that okay? Since minus pi is equals to minus pi comma 0 union 0 close pi, because if I draw my interval like this, if this is minus pi and this is pi, this is 0 is in between minus pi and pi. Is that okay? So I can still break, since I can break this interval into this interval, since this is equals to this, since, wait, let me take the duster. Since this is equals to this, it implies the interval what? 0, 180 degrees is a subset of what? Is a subset of this interval, is a subset of the interval minus pi. You understand? This interval, because this is here, we see clearly like this interval is a subset of what? This interval. So it implies let's just find values from S that are found in the interval 0, 180 degrees. Done. So from this S, what are the values that are found here? The values that are found here are simply what? Pi on 3 and pi on 2. So from S, we see that pi on 3 belongs to the interval 0, 180 degrees, and pi on 2 also belongs to the interval 0, 180 degrees. Is that okay? So it implies the solution for this part 2 will be equals to what? Pi on 3 pi on 2 with x belonging to what? 0, 180 degrees. Simple. So you can either decide to solve, do the same thing as we did before using the interval 0, 180 degrees, or you just use this deduction. You know that this interval can be broken down into what? This interval union this interval. If from this, it simply means that this interval is a subset of what? This interval. You understand? When you draw the number line, if this is minus pi, this is pi, this is 0. This is the interval open at minus pi, close at pi. You see that there is this interval and there is also this interval. You see that this other interval is what? It is a subset of this whole interval. Is that okay? It's very clear. So you just need to find values that were solutions of this that are found in this interval. Simple. I hope you understand what I'm saying. So that was all for this question. You will have to do this question, this, and the B part of them. you also have to do this question, exercise 5 and exercise 6. If you do all of them, I can assure you that you will never have problems again in finding the general solutions or solutions on a given interval of uh, trigonometric functions. So that was all. See you in the next videos that I'm going to do. That will be videos on integration. I will first correct the assignments you had to do, and I'll continue. See you in the next videos.